Okay, warm-up set 6, entry 5. What we want to use these figures to do is review our quadrilateral properties of the parallelogram, rhombus, rectangle, and square with numbers instead of just with the properties. So number one, first thing we want to ask ourselves, what shape is this? So I take a look and I notice opposite sides are parallel and congruent. So because the corners are not 90 degrees, I know that this is a parallelogram. So those properties will apply. So I have 30 degrees and 45. Since this is a transversal going through parallel lines, I know that I can fill this in as 30 and 45, like alternate interior angles. So the next question, I need to figure out what these other angles are. Sometimes drawing a figure to the side of the parallelogram without the diagonal sometimes helps people. I know that this entire angle in the corner is 30 plus 45, or 75 degrees. Same for here. So how do I find this missing angle? I know that consecutive angles are going to be supplementary or add to 180. So this angle is 105 as well as its opposite. So 105 and 105. Number two, I take a look at this figure, and I did not mark these as I had them on the warm-up. Sorry. Opposite sides are congruent, and I also notice that this corner is 90 degrees. So this means that this figure is a rectangle. And those properties apply. If this is 50 degrees, what would this angle be? We know the corners are 90, so this is 50 and 40. And again, alternate interiors, so 40 and 50. What we have to remember in a rectangle, and I'll draw one to the side, is that our diagonals are congruent. So what's special about that, yes, it does bisect each other, like it does in the parallelogram, but it just so happens that all four of those smaller segments are congruent. So this really means that these are creating four isosceles triangles. So we know that if two sides are the same, the angles across from are the same as well, or congruent. So if this is 40 degrees, so is this for that isosceles triangle. If this is 50, so is this. 40 and 40, 50 and 50. So again, all of our angles in the corner do add up to 90. They're complementary. Last but not least, I want to find out what my central angles are. So I see that I have created 4 different triangles. So if I look at this triangle all by itself, I see I have 40 degrees and 40 degrees for the base angles. What's left for that third angle? I know that triangles add up to 180. So if I have 80 degrees there, I have 100 degrees left for my remaining angle. Since these are vertical, I know this is also 100 degrees. And I can either use the triangle sum rule to find these, or linear pairs. Regardless of which way you choose, I know that 50, 50, and 80 add up to 180, or my linear pairs add up to 180. So there's the rectangle. Number 3 is our rhombus. And I know that because I have 4 congruent sides. So I see here that this angle is 40 degrees. What's unique to the rhombus, and it'll eventually share that property with the square, is that the diagonals are angle bisectors. So for the first time, unlike these ones, I know that if this angle is 40, so is this, because the diagonal bisects the angle, which then means these are 40 and 40. If I draw my mini rhombus for a second, I have 80 degrees in each of these corners. I know that opposite angles are congruent and that consecutive angles have to add up to 180. So if this is 80, that means these angles are 100. If I take it back to the picture, I know that the diagonal is bisecting these angles. So if the sum is 100, I know that each of those are 50 degrees apiece. And same for here. All right. And the other unique property to a rhombus that again will be shared with the square, is that our diagonals not only bisect the angles and bisect each other, they're perpendicular, meaning that my central angles are all 90 degrees. Number 4 is our square. We should notice that it has 4 congruent sides like the rhombus, but my corner angles are 90 degrees. So I know this is my square. What's nice about the square is that it shares all the properties of a rectangle and rhombus, which also or already include the parallelogram properties. So I can take my central angles first. I know that my central angles are 90 degrees. And I know that my corner angles are bisected. So half of 90 is 45 degrees. So all of the square angles will always be the same, no matter how big or small the square is. All of those angles are bisected.